Hello, we are Team 21, and this is the final code review and demo for the development of our application, Poste. Our sponsor identified a common issue that while billions of users save posts across multiple social media platforms, these saved items become difficult to organize, easy to forget. By the time users dig through their saved content, events might have passed or opportunities missed. Poste aims to provide a centralized platform where users can save, organize, and share those posts from all their different social media accounts, with calendar functionality for scheduling and reminders. This qualifies as a complex engineering problem for a few key reasons. It involves multiple disciplines with diverse stakeholders. We're building a mobile application that handles shared content across platforms, designing a backend API for data management, and balancing the needs of everyday users, our sponsor's vision, and Android and iOS platform requirements. There's no obvious solution because cross-platform integration isn't standardized. It involves many interconnected components like authentication, API integration layer, a database, and sharing mechanisms. And finally, it has significant consequences. Users are going to rely on this for time-sensitive opportunities like concerts and sales, where system failures could mean that they miss those opportunities. Before writing code, we formulated the problem through a few different artifacts like user stories and a UML class diagram. We start at the highest level with a use case diagram, capturing each interaction that a user could have with the system, like creating, editing, deleting posts and folders, sharing folders, logging in and out. Then we moved into the implementation level with a UML class diagram of the backend domain. Here you can see some entities, controllers, services, DTOs, clerk authentication layer, all laid out before we wrote production code. We used an agile workflow throughout both semesters, using Taiga for project management. We had 2-week sprints that were pretty closely aligned with our sponsor meetings. Here's an example of a user story from Sprint 6. We followed the template for defining user stories. As a user, I want to be able to sync time-sensitive posts to a calendar for organization and reminders. And each user story is broken down into individual tasks that can be claimed by a team member and tracked through until they're closed. Each commit that made it to main would be followed with a deployment to Railway. For most of the semester, the team had a working backend to integrate against, and our deploy history sort of doubles as our changelog. Authentication is handled through Clerk. The choice to use Clerk rather than rolling our own was a decision we made pretty early on. We'd rather rely on a security-focused vendor than reinvent OAuth and risk getting it wrong. The biggest architectural shift this semester was moving to Kotlin multi-platform with Compose multi-platform for the UI. Rather than maintaining separate Android and iOS code bases, the vast majority of our app lives in a single common main module. Every screen, view model, the navigation, the repository layer, all shared. When we do need platform-specific behavior, we use Kotlin's expect actual pattern. Here's our calendar launcher declared in common main, promises that each platform will provide an implementation but doesn't say how. The Android actual builds a calendar intent with calendar contract. The iOS actual uses EK event store from EventKit. The rest of the app calls one method, add to calendar, and doesn't know the difference between these two implementations. Our second pattern is the separation between state and UI. Here's post view model declared as an expect class in common main. It exposes a state flow of UI state and a handful of methods. Each screen sees the same API. On Android, the actual extends Android's lifecycle aware view model and uses view model scope so coroutines are canceled automatically when the screen is destroyed. On iOS, there's no equivalent lifecycle owner, so the actual uses main scope and exposes a manual cancel for the iOS layer to call. It's the same public API, but very different foundation underneath. We instantiate one post view model and one folder view model at the composition root using remember so they survive recomposition. From there, they get passed as parameters to each screen that needs them. Our third highlight is authentication. The challenge here is that Android and iOS handle auth and life cycles very differently, but the rest of our app, including the networking layer, can't care which platform it's running on. Our solution was to define one shared contract in common main and then let each platform implement it however it made the most sense. Here is the contract. Auth repository lives in common main, exposes a flow of auth state and methods for sign in, sign up, verification, sign out, and getting an access token. Each screen, view model, API call talks to this interface. They never see clerk. And here's the scene that our KTOR networking layer uses. Auth token provider is an expect object. Every API request asks it for JWT to attach as a bearer token. The implementations are completely different per platform, but the call site is the same. On Android auth repository combines three flows from Clerk's SDK, initialization status, the current user, and the session, and then it emits a unified auth state. The repository owns its own coroutine scope with a supervisor job, so a failure in one observer doesn't take down the others. When KTOR asks for a token, the Android implementation fetches a fresh one from Clerk using the Android API JWT template, which has a very critical name because the default Clerk JWT is rejected by our backend's authentication filter. iOS is a very different model. ClerkKit is Swift-only SDK, so we can't call it from Kotlin. Instead, Swift drives the whole auth flow natively. When it has a token, it calls into Kotlin through iOS Token Bridge. This is the scene where JWT crosses from Swift into our shared Kotlin layer. This works in the other direction as well. When shared Kotlin code needs to trigger a sign out, like on a 401 response from the API, it calls iOS signoutbridge.handler.signout. Swift implements that handler at startup, so we have a clean bidirectional bridge with Swift pushing tokens up and Kotlin pushing signout events down. Our last highlight is our Spring profiles and bearer tokens from the backend. Spring profiles let us swap the entire auth implementation based on which environment we're running in. So the real clerk filter runs in every real environment, local development, railway staging, production, and the mock filter only activates during automated tests, which lets contributors run our integration test suite without needing clerk credentials. When a request comes in, resolve bearer token pulls the JWT off the authorization header. Same filter still has a code path for cookie-based clerk auth, and that's how the website was originally going to authenticate, but mobile clients use bearer tokens, and this is the path that handles those. Authenticate bearer token verifies that JWT against the clerk secret key, which is set as a railway environment variable using clerk's lower level JWT session token verifier. And here's just a little proof of live requests against our railway deployed staging server returning real data from a real Postgres instance.
Hello, this is a full functional UI demo for the Poste application. This video will be sped up to double speed just for time constraints, so we will kind of quickly move through all the core functionalities. We'll start with logging in. We'll move to the user's personal homepage. And straight from here, we can create poster folders, so we'll create a folder now, give it a name. And now that that's created, we'll move to the folder's list UI. We can see it and open it and make any edits we need as the owner. Change here and save. Now we'll move back to home and just create a generic post with a Google address. Give it a title and a Google URL. Place it into our new folder. Now that that's been created, we see it straight from our post list UI. We can open it and make any edits we need as well here. Make a change. Now that we save that and place it into our folder, we can search that folder straight from home and access it and see the post. Open it up, and there it is. So now users can also share things straight into the application. So we'll start with a YouTube video, one we like. Share it to Poste and enter the information. Give it a tag and place it into a folder. And we'll notice here it will not let you create without entering a title. So let's try that. So let's throw one in there. And there it is. Users can also add websites, so we'll start with Wikipedia. Place it into a folder and add a description. And there it is. And we can also add social media. So we'll do an Instagram post now. Add a title. And I would like to point out here, when filling in something like an Instagram post, the description is parsed through and automatically added by the Poste app here. And just like title as well, if you don't place it into a folder, it will not let you create it. So let's throw it into a folder. And there it is. And now let's say we want to share a GIF with some friends. Share that in. Fill out its information. And there our GIF is in motion. Now let's log out and log back in just to share, or just to make sure all this is associated to the user. And there it is. Now let's say one of these posts we've created is a gathering with friends and it needs a date and or a time to be associated with it. We can go in, make an edit, add it to our calendar. And there on the native UI's calendar app, there it is, it creates it. And we can also do this just straight from post creation as well. Fill this information out. Set it to the next day. We'll give this one a time as well. And that saves it to the Phone UI's calendar application. There it is. So now that we have some posts created, we can search through these posts and open them straight from home. Open a couple up here. And now let's take a look at some of the user permissions we can grant when sharing. Go ahead and share this and enter a user email. And this one we'll just give you only access. We'll log in on their end. Open the folder list, and now there's the folder. And we'll notice here there's no options to edit any folder or posts of any, or delete. So we'll go back and we'll give them just a little bit more access. Refresh on their end. So for now, we cannot edit the folder itself. This will come back with an error code. But we can edit the posts inside. We'll go ahead and make a change here. And then we'll refresh on the owner's end. And there it is. Now let's give them a little more access and give them full. So we'll notice this adds a delete button to the post. So we can delete it from here. Refresh on the owner's end. And now it is gone. And we can also remove shared users. So let's remove him. Refresh on his end. Now there's no folders. And finally, we can open external links to anything that's been shared to us. Clean this up some. We can open a link here just after confirmation. There you have it. And this concludes our demo for the core functionalities of the Poste application. Thank you.